Hello, dear students. So, in our the previous class, I think we are studied this part, dehydrohallucination under the beta elimination reaction, sets a rule and the differences between the elimination and the substitution reaction. And the third part for that alkyl halides reaction with metals, which includes that with the sodium, that is nothing but that Woods reaction, and with magnesium, with lithium, with the lead sodium alloy, and the last part is that reduction, which includes the reaction with that hydrogen over that nickel and with the zinc copper couple. So now we are going to study the chemical properties of haloarenes. Okay. Okay, guys, let us continue the chemical properties of that haloarenes. So here in this topic, we are going to learn about that first starting that reactivity of what haloarenes compared to haloalkanes. First, see beta here haloarenes. That means this one. X stands for here that any halogen atom like that fluorine, chlorine, bromine, or iodine like. Okay, let us see. What is that? X is stands for what? Fluorine, chlorine, bromine, or iodine. And what about this? That haloalkanes. Haloalkanes like CH3, CH2, X. So comparing these two like that haloalkanes and that haloarenes, which one is that highly reactive means according to this statement that haloarenes are less reactive. What is that? The haloarenes are less reactive. So this is the order of what? Reactivity. This is the order of what? Reactivity order. Okay, so that means according to this one, haloarenes are what? That less reactive than that of haloalkanes are. So the reason is, whereas the halogen atom is here attached to those carbon, that carbon shown which hybridization beta? You have any idea? sp2 hybridized carbon. So here that halogen atom is the directly attached to what? sp2 hybridized carbon. Here it is also sp2, 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 sp2. So in that benzene ring, all the carbons are shown sp2 hybridization. But in haloalkanes, whereas the halogen atom is attached to here this carbon shown sp3 hybridization. Okay, sp3 hybridization. Now come to the point. According to that percentage of that s character in sp3, the percentage of s character means that s orbital is only 25%, but while in sp2 the percentage of s character is 33.33%. So which one is having that more percentage of s character? Huh? Which one beta? Obviously the sp2 hybridized carbon. So those halogen atom is attached to that more percentage of s character like sp2 hybridized is having least reactive. Why? Let us see. So here is the one carbon is there na? So the increasing in the percent of s character, what is that? Increasing in the percent of s character. Here the bond length between that means simply we can say as that nature of that CX bond means this is the carbon and this is the X. X is stands for what? Halogen. So the nature of CX, that means what? The distance. See here I'm already given the CX bond in haloarenes is a very short distance. So the nature of CX bond is that very low. Where beta? Where it is that very low, the nature of that CX bond, those percentage of S character is that more. like in sp2 hybridized of that is the benzene ring. So how much? Just 169 picometers. Okay, while here the nature of this one, the nature of CX bond, its a distance is 177 picometers. Okay, so which one is having the shorter distance? This one. So if it is the shorten, obviously it should be very strong, isn't it now? If the distance between the carbon and that halogen is that less, it would be that strong. Suppose if it is the strong, it is not easy to, what is that, it is not easy to separate out the carbon as well as that halogen atom, because it is that strong. Why it is strong? Because it is the shorten in the bond length. Why it is the shorten in the bond length? Because it's that percentage of s character is that more. That's it, very simple. So guys, sometimes like that we need to learn in that reverse manner, then it will be that easy for us to revise. Okay, chalo, carry on. So but whereas so got it na beta, like so here it is not that easy to separate out. That means that cleavage, the cleavage of CX bond is not that much easy because it is the strong. So that's why it is that less reactive. Clear? See, so CX bond is that haloarenes are the strong. So that's why it is that less reactive towards what? Nucleophilic substitution reaction. So which one is that highly reactive towards nucleophilic substitution reactions? Means halo alkanes are highly reactive towards SN reactions comparing to haloarenes. That is the main important point. Okay, and let us come to that next point. So due to the presence of here, see beta, the here pi bonds are there now, like this. So due to the pi bonds, is the benzene ring is that participate in that resonance due to the pi electrons. What type of that electrons? Due to the delocalization of the pi electrons. So that means that they can change their the position from that here, from that this position to this position or this position, like this, that where in that 11th class we are already learned. Do you remember, like in that aromatic compounds in that benzene? Okay, so the due to the presence of these, that delocalization, okay, the delocalization of that pi electrons, these that aromatic rings are participate in what? Resonance. Okay, so due to the presence of this that resonance effect, the CX bond in haloarenes, they acquire partial double bond character, as I said, like this, like this, like this. And so that's why the cleavage of that CX bond is becomes that more difficult here due to the, are very simple, due to the participation of that resonance. The cleavage of that CX bond is that difficult. That's it. Very simple. But what about over here in alkyl halide? There are no pi electrons. So pi electrons are absent. So that's why there is no delocalization. So that's why there is no resonance. So that's why uh, so that's why they are highly reactive towards what? SN, nucleophilic substitution reactions. Okay. So here we can raise a one question like which of the following compound is that highly reactive nucleophilic substitution product అని చెప్పేసి ఎలా ఇస్తాడు బెట ఆప్షన్స్ లో. ఒకటేమో ఇది హాలో ఆల్కేన్ కాంపౌండ్, ఇంకొకటి లైక్ దట్ హాలో అరీన్స్ కాంపౌండ్ హీ విల్ గివ్. ఓకేనా, ఆర్ యూ ఫాలోయింగ్ నా? లైక్ సో అలా ఉంటుంది, గుర్తుపెట్టేసుకోండి. నెక్స్ట్, okay guys, next come to that next point. This one, what is that? The phenyl cation. What is that? The phenyl cation is that unstable. So phenyl cation means, how can we write that? Phenyl benzene, this one is nothing but that phenyl cation. Okay, so that phenyl cation is that unstable, so it won't be stabilized through the resonance. Next, The benzene has that more electron density. This one, the benzene ring has that more electron density. So therefore, it can be as what? Stronger nucleophile than that of what? Than that of what? Haloalkanes like CH3, CH2. This is also R and this is also R. Na? So which one is that stronger nucleophile? Means that this one, because the benzene ring has that more electron density. Clear beta? So that's why it cannot approach it as that easily. Next, chalo beta. So next topic will be the types of reactions. So as is shown here, there are in that chemical properties of that haloarenes, we need to learn four type of the reactions. They are first one, okay, what is that? The nucleophilic substitution reaction, just as we learned in the previous alkyl halide SN reactions, isn't it? Huh? Okay, just a moment. Sorry. Okay, guys, sorry for the disturbance. Sorry for the interruption. Okay, next. So, yeah, what I am saying that in the previous topic we are already learned the properties of that alkyl halide, like same thing with like the nucleophilic substitution reactions, SN reactions over there we learn, and here extra electrophilic substitution reactions and reaction with that metals, as well as that the fourth one reduction. Okay, and next let us know that first one, nucleophilic substitution reactions. So in that alkyl halide, we learn the 13 types of the SN reactions example, isn't it? Now, do you remember the 13 types are there in SN reactions of what? Alkyl halide. We learn completely the 13 types. So what about over here? Let us see. So see. Mm, yeah. So in the nucleophilic substitution reaction, just we have only the three, whereas the first one, replacement by amino group. So this one is that replacement by amino group. Amino means we already know na, amino group means this one. Okay. So when haloarenes means this one. When haloarenes is reacts with that liquid ammonia. Okay. When haloarenes is reacts with what? Liquid ammonia at 475 K under that 60 atmospheric pressure. So that halogen atom of that haloarenes, this one, sorry, this one, yeah, yeah, okay. So then halogen atom of what? Haloarenes is going to be replaced by, replaced by what? Replaced by amino group, means this is that ammonia NH3. Amino means NH2. So it is going to be replaced by what? Halogen atom. So in the presence of what? Cu2O as a catalyst. So this is the main important one, don't forget. Okay, so here what happens in NH3, in liquid ammonia, NH2 can be as what? Nucleophile, whereas the remaining that hydrogen is one less na, that hydrogen is going to be reacts with what? Oxygen atom of this, that cuprous oxide. Okay, and remaining this, that chlorine is reacts with what? Copper, and exist as a CuCl, and the remaining that water molecules can be existed under 60 atmospheric pressure. So then we can get that aniline. Okay, so that replacement by amino group. Clear na? Next, replacement by cyanogropa as usual. What is that? That halogen atom of this, the haloarene, is going to be replaced by cyano, means what? Cyanide, and gives phenyl cyanide. Otherwise that in the common simply we can say as that cyanobenzene. Okay, but here these the credentials are that very important one. So when that haloarenes is reacts with what anhydrous CuCN, copper cyanide CuCN, okay, in the presence of what pyridine or dimethyl formamide. Simply we can write it as what DMF, dimethyl formamide. Then finally it gives what cyanobenzene. And what is the byproduct? CuCl. CuCl is the byproduct. Okay. Whereas that cyanide ion is a nucleophile, is replaced by chlorine. And whereas this that chlorine is that exists with the copper as CuCl. Next, go for third one. Okay. So here what happens, in the third one, what is that? Replacement by hydroxyl group, very important one. Okay, according to that board, that means that IP point of view is also important one for that VSAQ for the 2 marks question is that Dawes process. Okay, so in this method, yeah, so in this method that chlorobenzene is that converted to phenol. So this is the important one, don't forget the conversion of that haloarenes to phenol, important one. Sometimes these the conversions is also can be given in that mains and that NEET point of view, but not like this type of that very silly, but we can't say na beta. So according to that NCRT mode, we can, we can't justify like that. Okay, see, so how this that chlorobenzene is going to be converted to, that means that haloarenes here. Okay, so conversion of that haloarene to phenol through Dawes process. Okay, next, see, so in this process, actually the Dawes process is used to manufacture of that phenol from chlorobenzene, important one. So the conversion of chlorobenzene to phenol, that means that phenol is going to be prepared through the Dawes process with the help of what? Chlorobenzene. So whenever this that chlorobenzene is heated with the aqueous NaOH, this one. Okay, whenever the chlorobenzene is reacts with that NaOH, why we are going to get that NaOH means why? Because H plus ponga migta the compound ఏమవుతుంది beta ONA. Okay, NaO minus, where it can be has what? Nucleophile, isn't it? So whereas that halogen atom should be replaced by nucleophile as that NaO. So that's why then we will get that sodium phenoxide, sodium phenyl plus this one is that oxide, so sodium phenoxide. Okay, yeah, come to the point. When the chlorobenzene is reacts with the aqueous NaOH at 300 atmosphere pressure, okay, and loss of this that NaCl. Okay, this is that after beta, so not now. Okay, idanta tarvata. So it first it gives that sodium phenoxide. So further on acidification means H plus, it gives the phenol on loss of what? Na, and this one chlorine can be removed as that. So see here that Na plus is going to be moved out now. So this one can be reacts with that chlorine and form that NaCl, the salt, and remaining these OH, and here yeah oxygen is there, Na. Okay, ఇక్కడ acidification ఉంటుంది కదా, okay na, so that can be removed as that, this oxygen as that, this acidification can be removed as that what? Water molecule. So that is nothing but the Dawes process. So once again the Dawes process, what is that? The Dawes process is mainly used for what? Formation of what? The phenol. Phenol from what? That chlorobenzene in the presence of what? Aqueous NaOH. First it gives that sodium phenoxide. Further on acidification it gives that phenol. That's it. So here one important point should be noted, that is nothing but see beta. See beta, so here one of the very important topic is there. So as we observe that the increasing number of that electron withdrawing groups, that means that we know that electron withdrawing groups is nothing but what? Minus I groups, isn't it? So if the increasing in number of this that electron withdrawing group over, yeah, over what? Haloarenes. This is one of that haloarene. Okay, So here, tell me better, how many number of that electron withdrawing groups are there? In the first one, only one. How many are? Only one. In the second one, two minus I groups are there. In the third one, three minus I groups are there. Means that electron withdrawing group. So increasing in number of these, that minus I group. Minus I stands for what? Negative inductive effect. Ah, minus I stands for what? Negative inductive effect. Is gives the explain about what? Electron withdrawing. Simply we can say as that EWG group, electron withdrawing group. So for that haloarine, the reactivity is also increases. What is that? So more the number of minus I groups, more will be the reactive. Clear? Okay na? Chala. Next, come to the point. Let us go for that explanation. See, in the first one, what is the name of the compound? And chloro 2-nitrobenzene. First it reacts with what? First it reacts with what? Aqueous NaOH. According to that same, that the previous whatever we learned as the Dawes process. First it gives what? Only this one, the halogen atom of that benzene ring, means aromatic, is going to be replaced by nucleophile. What is the nucleophile over here? ONA. See, so that's why just we written like this, ONA. And NO2, there is a no change. There is no change in this, that NO2 means that minus I group. Okay na? So so further this compound and acidification. Yeah, finally it gives that to nitrophenol. Clear? So increasing in number of these groups, increasing in number. So finally it gives the 2,4 dinitrophenol. What about this? 2, 4, 6 trinitro-chlorobenzene, but the reacts with that aqueous NaOH, which contains ONA as a nucleophile, whereas the chlorine is going to be replaced like this. Okay, first it gives that is the phenoxide ion, means that sodium phenoxide of what? 2, 4, this one 2, 4, 6 trinitro sodium phenoxide. Further on acidification, that means the dilute HCl, it gives that 2, 4, 6 trinitrophenol. That's it. Okay, next. So this is the first part, the nucleophilic substitution reactions of haloarenes, which includes only that three types. What are they? First, replacement by amino group. Okay, na? These are the main important one. Don't forget. This one is the very important one. Don't forget. Okay, next, the second one is that replacement by cyano group, and the third one is the replacement by hydroxyl group, is followed by what? Dawes process. Okay. So in the Dawes process, what is the main reagent? Beta, aqueous NaOH. That's it. Okay. And one more important point should be noted over here, like that increasing in the number of this, that minus a group over haloarenes, that the reactivity is also increases. That's it. Okay. Next, go to that second one, electrophilic substitution reactions. Okay. So in that haloarenes, what's going on over here? Let us check. What is that? In haloarenes, the halogen atom, this one, the halogen atom in the benzene ring directs the incoming substituents. So this halogen atom is that directs to what? Any another atom. Okay, it can direct the incoming substituents. Where on that, which position? At that ortho position, this one, or para position over here, otherwise that over here. Let us see, whenever that halogen atom, one of that pair of electrons, if it is see that I will show you, if this that pair of electrons can attack over here in the next structure, what happens is that halogen atom is going to be destabilized. because it contains only 1, 2, 3, 4, 5, 6, 7, 8. Now in the first structure it contains that 8 electrons, but after the shifting of this that pair of electrons over here, next the single bond is converted to double bond, whereas there is that halogen atom is that vacancy. So that's why here it's shown a positively charges. And whenever these that pair of electrons are shift over here the double bond is obtained, isn't it now? So that electron density will be more because that already that pi electron is there. So that's why here it's shown that negative charges, so more electron density. So that's why it is not that possible, it is not be stable at that ortho position, which it can next converted to is attacked to where meta position, this nucleophile. Okay, this negatively charged ions, okay, can attack it meta position, but it is not that possible. Meta, it is the negatively charged ions is that not meta directing groups, we know that. So that's why it again attack to the where and para position. So in that first year in the class 11, the same topic we learned. Okay now. So first it is that nucleophile is settled at after shifting of these that electrons, they comes to that first ortho position, next para, next ortho, that's it. And finally we can get the same structure, but just like that mirror images, the first one and the second one. See here the I will get that another color. See for this that benzene atom, that left side of this that double bond, this one here it comes that right hand side, and right side of that top here becomes as that left side of the top. Here the right side of that bottom here becomes as the left side of that bottom, just mirror images. So let us see in structure second one, third one, fourth one, the negative charges where it is located, the negative charge is located at that ortho and para position. See, this is that ortho, para and ortho in which structure 2, 3, 4, which indicates that that electron density, as I told you before only, what is that, the electron density will be more at that ortho and para position. So hence the incoming electrophile is more likely to attack and this one, whatever that electrophile means, the positively charged ion is going, it wanted to attack wherever that electron density will be more, like ortho, para అండ్ ఆర్థో పొజిషన్, అంటే వచ్చే ఎలక్ట్రాన్ కూడా మళ్ళీ ఇక్కడే అటాక్ కావాలని చూస్తుంది బట, ఈస్ మోర్ లైక్లీ టు అటాక్ ఆన్ దిస్ ఆర్థో అండ్ పారా పొజిషన్ టు గివ్ ఆర్థో అండ్ పారా సబ్స్టిట్యూటెడ్ products. Clear? So this is the little bit that basic. Now based on this that basic, okay, let us give and let us learn the few examples. Okay, halogenation. Okay, come to the point. Halogenation, when chlorobenzene or haloarenes is reacts with what, chlorine. Just a moment. Yeah, halogenation when that haloarenes is reacts with that halogen in the presence of Fe or FeCl3. Okay, whereas that FeCl3 can be as what, Lewis acid. Okay, what happens, FeCl3, first it is that one mechanism is that first FeCl3 lo FeCl3 లోంచి one of the chlorine atom, okay, ఇక్కడికి వెళ్తుంది, అది ఏమవుతున్నప్పుడు FeCl4 అవుతుంది, that remaining that chlorine can be as what, electrophile. This that electrophile can attack and which position beta, at that one is that ortho position and next at the para positions only, but not at that, see here that one ortho and para position according to this. Why? Here that ortho and that para position, that electron density will be more, so that's why which can is that easily likely to be that attack for the incoming electrophile, chlorine plus electrophile. So that's why then it gives that ortho dichlorobenzene is that one product and that para dichlorobenzene, whereas the para dichlorobenzene is that major product. Why so? So more number of that alkaline groups are there between these that two. Okay, chlorine chlorine here that two, but what about over here that less number, అసలు లేనే లేదు బేటా. సో అందుకే This that para compound is a major product. This is the halogenation. In the class 11th we are already learned. Next, nitration. Nitration ante em తీసుకుంటే బెట మనం nitration mixture. What is the nitration mixture? C is already given. Nitration mixture. What is that? The concentrated HNO3 plus H2SO4 is nothing but that nitration mixture. Okay na? Which it is taken at that must and should. ఇది మర్చిపోదు రోయ్. ఏంటది 50 to 60 degrees Celsius the temperature. ఇది మాత్రం కంపల్సరీ. అదర్వైజ్ దట్ సింప్లీ వీ కెన్ సే ఇన్ ద నైట్రేషన్ లో లెస్ దాన్ 60 degrees Celsius అని కూడా ఇస్తాడు ఒక్కొక్కసారి. లెస్ దాన్ 60 degrees Celsius అని కూడా ఇస్తాడు. సో HNO3 మనం ఎలా రాసుకోవచ్చు? ఇది యాసిడ్ కదా, రిమూవల్ ఆఫ్ దట్ బేస్ కాంపౌండ్ OH మైనస్ పొంగ ఇంకా మిగతాది ఏముంటుంది బేట NO2. సో దట్స్ వై వీ కెన్ సే HNO3. సో NO2. ఓకే, సో HNO3 లోంచి it is that NO2 ఏదైతే ఉందో that can be attacked at ortho and para positions like this. Ortho and para positions. So ortho దగ్గర ఉన్నప్పుడు ఏం ప్రోడక్ట్ ఫామ్ అవుతుంది? What type of that product is obtained? 1-chloro-2-nitrobenzene. Otherwise that ortho nitrochlorobenzene. This one should be para nitrochlorobenzene. Clear? So according to this, that which one should be that major product? Obviously this one only. Okay, come to the next page. Chalo beta, the next third one. So first one is that halogenation, second one is that nitration, and the third one is the sulfonation. Chalo. So in that sulfonation, the chlorobenzene is reacts with what? Sulfuric acid, H2SO4. Here it is also simply we can write as what? That OH minus and HSO3 plus. So which one is needed to be that attack? Electrophile. Electrophiles is going to be, because here we are learning, don't forget, is that electrophilic substitution reaction. So here electrophile is going to be attack where? In that previous we are already learned. What is that? More likely to be wherever that electron density will be more. Where is that electron density should be more? At that ortho position and that para position. So this that HSO3 or SO3H plus can be kept at that ortho position, means that here like this one. Okay, otherwise para position here. Okay, so then it becomes a 2-chlorobenzene sulfonic acid, and this one that 4-chlorobenzene sulfonic acid. Obviously this one is only main product. So this is the third one. Next to fourth one, Friedel-Crafts alkylation and acylation. So very important one. Okay, according to that board level and that IP point of view. So whenever this that chlorobenzene or that haloarenes is reacts with that alkylation, indulone undi beta meaning, whenever it reacts with that alkyl, CH3 and Cl, means alkyl halide in the presence of anhydrous AlCl3, which can act as what? Lewis acid. Okay, so which is going to be attacked to that chlorobenzene, means that haloarenes R plus X minus. So electrophile should be that substituted. So that means R plus. So that means that CS3 can be attacked at that ortho position. Okay, likewise what type of that compound is obtained? 2-chlorotoluene. Otherwise that orthochlorotoluene and that parachlorotoluene is that obtained. So this is the Friedel-Crafts alkylation. Next, Friedel-Crafts acylation. Just like when haloarenes, means that chlorobenzene is reacts with that acyl chloride, means CS3COCl. Like simply we can say as that RCOX. In the presence of same anhydrous AlCl3 can be has what? That Lewis acid. What is that electrophile over here? X is always that minus, remaining that RCO will be that plus, means COR will be that electrophile is going to be attacked at that ortho position, like COCH3. So what is the name of the compound? 2-chloro. This one should be known as what? Acetophenol. Okay, this one parachloroacetophenol. Chalo, which one is that major and minor? This one. Para product is that major, whereas that ortho product is the minor. Clear? So this is about that second part. So that first part of the chemical properties of this that haloarenes. That first part is that nucleophilic substitution reactions, which can include that 3 reactions, and that second part is that electrophilic substitution reactions, which includes that 5. Okay, next go to the third one, reaction with the metals. Clear? Okay, chalo. So next the third one is the reaction with that metals, and remember the fourth one is that reduction. So now we are going learning for the third one, reaction with that metals. So how many types are there? First one, reaction with that magnesium, reaction with that sodium, lithium, and copper powder. Okay, first let us know that first one with the magnesium. So when haloarenes are that reacts with that magnesium, see the one of the statement is there. What is that? What is that? Aryl chlorides, they don't form Grignard reagent in the presence of what? Ether. So that's why in the presence of the tetrahydrofuran means that THF, they form that RMGX, means that Grignard reagent, like that chlorobenzene when it is that reacts with that magnesium metal in the presence of not that ether, THF, tetrahydrofuran, then it gives that phenyl magnesium chloride, which it's nothing but what? RMGX, means that Grignard reagent. So here aryl bromides. So okay, chlorides can give, but what about that bromides and that iodides? Aryl bromides and that iodides from the Grignard reagent with the magnesium in presence of what? Ether. But chlorides only can give in the presence of what? Yeah, yeah, in the presence of what? THF. Okay. Chala. Sorry, I need to be that clear this one. Yeah, it's clear. So let us see that one note. So aryl bromides, like this one, aryl bromides and that aryl iodides, when react with that magnesium in the presence of ether, they will give what? Grignard reagents. So very simple thing here. Next, go to that second one, reaction with that sodium. Yeah. So in that alkyl halides reacts with the sodium, it is nothing but that Wurtz reaction. But this one, when haloarenes is reacts with that sodium metal in the presence of that dry ether, it will be the what? Fittig reaction. What is that? When haloarenes is reacts with that sodium metal in the presence of dry ether. Okay. But whereas that haloalkanes, what is that? Can you know that alkanes are obtained, means alkyl halides are converted to alkanes. But what about over here? Not alkanes. Here, this one is the one of the phenyl ring is going to be combined with that another phenyl ring. Just as usual, they can give that two phenyl rings unite. Okay. Simply we can say as well that diphenyl ring is that obtained in that Fittig reaction. And what is that byproduct? Sodium chloride. So please check the balance in the equation. Okay. Next, chalo. This is the second one. Come go to the third one. Third one will be Wurtz-Fittig reaction. Sorry, the continuation of that Fittig, the Wurtz-Fittig reaction. What is the Wurtz-Fittig reaction? When haloarenes is reacts with that CS3Cl, means that Rx in the presence of sodium metal in the presence of ether. Wurtz-Fittig reaction. From to combine just like sodium metal as well as that alkyl halide. Both should be taken over Wurtz-Fittig reaction. Then what type of that compound is obtained? Hmm? Methyl benzene. Methyl benzene is obtained, means that just like the toluene is obtained. Okay, that is the Wurtz-Fittig reaction, important one according to that IP point of view, and the like that board level. Okay, Fittig reaction means Wurtz reaction, Fittig reaction, Wurtz-Fittig reaction. At a time you need to be that practice. Okay, now so don't get confused. Wurtz reaction, once again I am saying. So Wurtz reaction, Fittig reaction, and this Wurtz-Fittig reaction. At a time you people need to be that practice on the paper. Clear beta? Next, go to the third one. Yeah, reaction with that lithium. Simple. What is that? When haloarenes is react with lithium in the presence of dry ether, it forms that corresponding organometallic compound, like this one, phenyl lithium. What is the byproduct? LiCl. Okay. So these organometallic compounds behaves as that Grignard reagent. Very important one. This one, this one, this one. Beta. Don't forget. Very important one. So the organometallic compounds which it is obtained when that haloarenes is reacts with that lithium metal in the presence of dry ether, they give what? Organometallic compound, and these organometallic compounds can behave as a Grignard reagent. Okay, చాలా important question అది, important point, people should be noted. And next, that fourth one, reaction with that copper powder, that is nothing but that Ullmann reaction is the named reaction. Okay, now is the very important one. When iodobenzene is heated with that copper powder in a sealed tube, it gives the diphenyl, just like what? Fittig reaction. So fittig reaction లో ఇక్కడ కూడా మనకి ఇగో ఏం ఫామ్ అవుతుంది బెట? డైఫినాల్. ఇక్కడ కూడా ఏం ఫామ్ అవుతుంది మనకి? Diphenyl. Otherwise, that simply we can say that biphenyl. But here we are getting that chlorobenzene reacts with that sodium metal. కానీ ఇక్కడ ఏంటి? Iodobenzene with copper powder. అది మాత్రం మర్చిపోవద్దు, ఇంపార్టెంట్ వన్. కానీ ఇక్కడ బై ప్రొడక్ట్ ఏం ఫామ్ అవుతుంది? వాట్ ఈస్ దట్ బై ప్రొడక్ట్? CuI2. Okay, CuI2 form. Okay? That's it. Next, go to the last one, the reduction. Okay, guys, like that, if you wanted to revise once, like that, you can write down the notes as pause the video, and you can revise that one more time also, just if you won't follow the properly, because that this is that very easy topic, so that's why just I am moving that very fast. Okay, chalo. Next, fourth one, reduction. When haloarenes is reduced to, is the reduction. So reduction means that must answer to that reducing agent. What is the reducing agent here? Nickel Al means nickel aluminum, like it should be known as that one alloy. So presence of what? Alkali, that means that NaOH. Then it releases what? Nascent hydrogen. Then it releases a what? Nascent hydrogen, like this. Okay. Hello. Now this that halogen atom is going to be replaced. Means just moved out and gives only what? Benzene. So haloarenes are going to be reduced to arenes. Haloarenes are going to be reduced to arenes through the reduction. So these are the four types and the chemical properties of haloarenes. Okay, chalo. In the next video, in the next class, we are going to learn this one. Very, very important. So just I wanted to clear this one. Yes, now it is done. Yeah, next topic will be that the nucleophilic SN reactions, means that SN1 and SN2. Very, very important topic. Can be learn next video. So till then, bye bye. See you in the